There's a part of LibreTexts you may not be known of when you go to courses, and most of the courses are based on campuses. But we created a place called Intercollegiate Courses, and the idea here is that you can actually, this comes from the OLCC, and Harry Pence was involved with the very first one of these in 1996, which are online courses run by the American Chemical Society class. In 2019, we created a Cheminformatics OLCC that was taught on 5 campuses in the US and Spain. And I've also been developing one on the Internet of Science things. So if you go to courses, Intercollegiate Courses, you can find these. And I'm gonna just take a quick morph into this Internet of Science things class. It wasn't my intention to, but I think it may be of value to some of you. I'm not sure how many of you have heard of POGIL, Process-Oriented Guided Inquiry Learning, but this is a program that actually started in chemistry, and they have a bunch of modules. There's a thing called CS POGIL, Computer Sciences POGIL, and these are modules that they have that we've converted over into LibreTexts, and we got permission from them. It's one of the few things that POGIL has made open. And so those of you who might be interested or are familiar with POGIL might find that of interest. The course that we taught, actually, there's a sort of interesting story here. I'm going to be a little bit adaptive here. The Cheminformatics OLCCs are the longest ongoing online course that I know of, the first one in 1996. In 2017, we ran one on PubChem, and it used a lot of PubChem services. And in 2018, the current government reduced NIH's budget, and they removed many of the PubChem services. So here we're showing you structure clustering tools. Here we're showing you the ability to make heat maps and dendrograms. And if you go to any of these services, they're all deprecated, okay? PubChem, these are called legacy tools. And these tools for activities, structure activity relationships, structure clustering are no longer being maintained by NIH. So I got together with some of the staff at NIH, and we decided to create a course that taught that material that the 217 course did, but used open source material. And so we created a course designed for chemistry students who have had no programming at all. And this course took them up through machine learning. And this is the outline. And it started with how to install Python. We used the Anaconda package, how to install R. Oh, I didn't say this. Not only was this course taught in Spain and America in 2 human languages, but we did all the modules in 2 programming languages. The original ones were created at NIH PubChem with Python, and then Jordi Madros in Barcelona translated them into R. And I'll show you how the Jupyter Hub could be very effective in that. And what we had the students do is download the Anaconda package. And in the Anaconda package, we have many things that we uploaded to the Jupyter Hub. So we have pandas, we have scikit-learn, NumPy, and all the associated libraries. So we have both the libraries and packages that the students would run on their own computer, but they've been run on the Jupyter Hub. And at this point, maybe I should describe what is a Jupyter Notebook and what is the Jupyter Hub to the best of my ability. And first off, when you go to Anaconda, what you install is the Jupyter Lab. And the Jupyter Lab is ability to run multiple notebooks. So this here is a Jupyter Notebook. This here is a Jupyter Notebook. This one is running in Python. This one is running in R. And so I can run both of these kernels at the same time. I don't have to be running 2 different programs. This is one of the nice things about the lab. And I can run 2, let me get that over here. I can run 2 Python programs and move, and if I want to compare my programs, I can scroll down. So, okay, I can scroll down to here, compare my code here. Let me get rid of this one in R, and compare my code here. And so I can move, so I can troubleshoot programs, I can compare programs. what Jupyter is this is in markup, and then this is in R. And so, for example, if whoops, I didn't mean to hit that. I hit a link in there. If I hit Shift Enter, I go through the markup text, and then if I come to some code and it runs it, so I've now imported requests. Now I'm going to PubChem, and I'm using PubChem's API to get a molecular property for aspirin, the molecular formula. And now I've got that, and now if I go down here, I can print it, and this is the molecular formula for aspirin. And so this course moves students through this. The advantage of the Jupyter, and now what you are looking at is a Jupyter hub. So this is a lab in the hub, and the hub allows me to access this from any computer. So the computer I'm on may not even have Python installed. It may not have Jupyter installed, but my students are able to run it. So for example, if I'm teaching, I don't know about your school, but in my school, our IT services won't let you install anything on the computers. I mean, they're just nasty. And so if I went into a lecture room, I couldn't show this stuff without having to go through a lot of bells and hoops to get IT services to install Jupyter on that computer, and then upload all of the libraries or packages that I need. With the Jupyter Hub, I can do that. So I can go down the street to my friend's house and have instant access to these resources, okay? And I'm gonna let somebody else describe how, and since I did this course, they've done the binder, which you've heard of. And at this point, let me ask if there are any questions. And if not, I will pass this on to others. But one of the powers of LibreTexts is all this work that we've done, both in the cheminformatics class and the Internet of Science Things class, is available to anyone. And we have somebody else who's converting this stuff to Mathematica, but that's work in progress. And through the hub, we were able to run a course in Python and R on cheminformatics that took students up through the basics of machine learning. Any questions? So our hope is that once we finish our 3 quick presentations, any of you that would like to try and embed some script into your web page, last thing before I do call it quits. In order to get into this hub, I had to sign in. The binder that you're about to be shown, so I'm going to open in a new incognito window, and so I can come here, and if I now go to the Python assignment, and my students could download the notebook and run it on their computer, or my students could go to the hub, and I have to sign in. And so you can't go directly to the hub without getting an account. But today, you will be able to use Binder without having an account. And I'm on my wife's computer. I can type my email, and I'm able to log in through my UALR email address. So I'm set up to log in through my UALR, and so the hub can be directly integrated into your campus access. And now I've entered the hub through an incognito browser, and I have access to all of my files. And all I had to do was drag these from my computer into this area here. And we can let somebody else describe more of the details if you're interested, but I think I'd like to turn this over to either Kamran or Magali, whoever would like to go next.
Kamran's been doing this a bit longer. I think maybe he should go first.
Oh, I think he's been doing it less, but he's more than welcome to go. Actually, that would be good because Kamran's only done the binder and you've done both, so it'd be good if you tied this all up at the end.
Okay, sure.
So with that, let me stop sharing my screen. And Kamran, can you share a few things with us?
Okay, let me share my screen. Okay, can you see my screen now?
Yes, we can.
Okay, great, good. So as Bob mentioned that, I mean, I have started working with the binder, and the binder is something which is more useful. I find it useful because I didn't have to download the Jupyter Hub or the Jupyter Notebook. Of course, I mean, Jupyter Hub has a lot of capability which I would like to use at some point, but for now, I'm just using the binder. So for binder, if I have any LibreTexts page over here, and if I go into the edit mode, so it gives me this binder symbol here. This is to enable binder. So binder just binds in the Jupyter Notebook into the LibreText and allows you to insert code. So for example, for this workshop, I was trying to work on some simple examples in R, whereas, I mean, R is not the regular language that I use. Some of my students do use R, but I normally work with MATLAB only. But if I point my cursor over here and click the enable binder, so it allows to insert a interactive script here. And the choices are that I could use a interactive script in Python, or Julia, or R, or Octave, or Sage Math, or C++. So if I want to choose R, then I'll just keep R over here, and then I can erase this or delete this script, which is just a default script to show that I need to enter script over here. And I can define a variable, for example, X, and let's say 1 through 10, and then run it. So it takes a little while for it to come up because it loads the kernel first, and I should get some output at this point, but if I save it and run it from here, it says waiting for the kernel, it'll come up in a minute, and then it'll show the output.
I think, Kamran, you're not going to get output because you're just storing it. You need a second line where you've got the X by itself.
Okay, well, I mean, I did this couple of other examples in R, for example, to sample the input, and let's get a sample with two entities. Similarly, to plot a histogram in R, I could do that. So those are a couple of R examples, but basically all of them were created by using this binder option. And then in my own work, I'm creating this textbook on control systems, Introduction to Control Systems. And if I go, for example, to one of the pages in my book, let's say first order ODE models. ODE is for ordinary differential equations. So on this page, then I have several examples of ODE models, like for example, a RC network or a parallel RL network, maybe a inertial mass dragged by a force, or a room heating example, or a hydraulic reservoir. And then I talk about solving the first order ODE models. And at the end, I have a graph where I plot the output for the first order model. So I put in this example in the Octave. Now, Octave has several toolboxes like MATLAB has, and those are called packages. Like, for example, if I go to the Octave page over here, so it has all these packages created by different members in the Octave community. And there's a whole bunch of packages. I mostly use the control package for my work. So that's what I have here. The first command says that load the control package before running the code. And then I define a complex variable S, which is used for the Laplace transform. And then I define a transfer function, a simple one, 1 over S plus 1. And then I plot the step response by using the step command. So all these commands are from the control package in Octave. And after plotting the step response, then I highlight the response at multiple of time constant, like 1, 2, 3, 4, 5 time constants. The plot above was actually created by MATLAB. And this code will create a similar plot with Octave. Let's say if I run it, again, I have to give it a minute for the kernel to load. The first time it does take a little while for the kernel to load, but after that, for the subsequent examples, they are run pretty much, I mean, almost in real time. Although I did load the example earlier, but it's still gonna take a while for it to load. So I guess we just give it a little time for the output to show up. But when it shows up, it'll be similar to this output over here, which is from MATLAB. The plotting capabilities of Octave are not as sophisticated as MATLAB is. So the plots do look a little crude as compared to MATLAB, but it does the basic work. So for this then control systems book, I mean, I have included several examples of using Octave where I can insert the Octave code, and somebody who is following the book, he or she can then run this example from here and see the output.
So Kamran, from chemistry, have you ever heard of the first law of crystallization?
Well, the last time I did chemistry was in high school. Well, probably maybe first year of engineering.
It will never crystallize as long as you're looking at it.
Okay. All right.
I think this is the first law of kernels.
Okay. And similar to the Murphy's law, that something can go wrong, it will. So, yeah. But yeah, so I'm going to just skip over it. But basically, I mean, that is the procedure to insert binders. That anywhere on this page, let's say going down again, maybe at the end of the page, and I can go to this edit session or edit section, and this allows me to edit the input. Now, all these, the equation have been written in LaTeX, and I can go over here and then click the binder option and then start typing the code here. So in my case, all codes will start from package load command, where I load the control package, or I could load some other packages and then start defining the Octave commands over here. Save it by using OK, and then run it by, first save it and then run it by clicking the run button at the end. So let's see if it has loaded it yet or not. I'm still waiting for the kernel. Okay, so we'll skip over here. And let me just go over a few other examples of Octave. Okay. Let's go to this Octave examples, which I just created for the workshop. So I have examples, for example, this is to create the net present value of a series of payments. And for that, I have to load the financial package from Octave. And then I can define the payments, I can define the interest rate and compute the net present value. Let's see if this one runs now. Okay. I have a data smoothing example over here where I use the random command to generate random numbers, use a sine function to create a time series, then add some noise to it, and then use this get data, regular data smoothing command from Octave to smooth this data and to find a data fit for it. And this command uses the data smoothing package. So I have to use the package load data smoothing at the beginning. Similarly, if I want to, for example, create a linear algebra example where I create the SVD of a matrix, SVD is in the regular Octave package, so I don't really need to load a particular package over here. I can just define a matrix of random numbers and then use the SVD command to create the SVD for the matrix. And that's a bummer. Okay, so that's pretty much, I mean, I have to show for the use of the binder and for using the Octave with the binder. So I'll hand it over to Magali and she can explain her work with the Python.
Thank you.
Okay, let me get to.
Okay, so I'm going to share my screen also and show you how we're adding in Python notebooks. So this is, let me go back to the top of this page. This is a textbook that I'm creating, and what we've decided to do in the textbook is at the end of each chapter we have an example notebook which goes through one of the calculations from the chapter. As we've been going through this, I realized that students need to have very clear instructions on how to use this, so we've put these instructions at the top in terms of how to work through this Python notebook page. And if you've never used Jupyter Notebooks, I think Bob touched on this, that you can have sort of windows with text that kind of give you instructions and then windows that have code. And really the LibreTexts book page works in the same way. We can write text and then we can have these boxes, as Kamran showed, where we can put in the code that we enter in with the binder. And so then this code is actually being run on some computer somewhere else, and the output of that code is being displayed real time on the notebook. So I already went ahead and started mine, so my kernel already ran. The other thing we've decided to do in these boxes is we've added little print commands so that the last thing in each command window tells the student that that command is done, like it's completed, and that they can go to the next box. And that's because some of the windows don't actually create any output, but we are actually explaining how what the Python code is doing in each window. So here we just load packages. So this is in Python, we're importing several packages from Python, and we define some variables. And so I already ran that box, so I don't have to run it again. And so that's another thing about these pages, is that a page is sort of like a series of connected code, right? So if I run the first box, that information actually exists and is available to the next box in the same window. So in this window, I've already run this, but I can run really quickly, and I've defined some functions and parameters that I use. And the text in between is explaining to the students what each of these steps is, so that they can connect it to the equations that we've already gone through in a previous section. And so then this box here is actually setting up the figure that is now going to run the output of the functions that they've defined. And what you hopefully all just saw is that this actually runs in real time. And this is actually doing a for loop here. So we're looping over a range of angles, and what we're calculating is the flow field, the velocity profile, and the strain rate in a layer of magma flowing down an inclined plane. So one of the other things we've did in here is, we have this output here telling the students that they can change the pause time, right, in case this is going too fast or too slow given their connection. So another thing that's interesting about this is that the students can actually edit this. So I can come in here as a user, change this, and maybe I'll change it more so that it really looks different, and then click run, and now it's going to run, and now it's going much slower, right? So that it really just, you can see each of the profiles being plotted as they're being plotted. We're using these for loops right now as sort of a plan B to what we actually wanted to do. In Python, there's a package called IPyWidgets, which allows you to create these figures with little sliders where the user can then slide back and forth the parameters that they want to change, and then it would real-time update the figures. And it turns out that right now the IPyWidgets doesn't work with the binder, but I wanted to share this with you because as soon as I realized this, I contacted Jason Moore, who is the person who's working on these binder and Jupyter Hub things. And they immediately started working on trying to fix this. They knew it was an issue, and it's actually related to the binder, which is of course a set of software that's supported by some other group outside of LibreTexts. But they're now working with us to see if we can get the sliders working. But in the meantime, this is a kind of a plan B to allow us to have figures that show how the solution to an equation changes as we change one of the key variables for that solution. And so then this goes on. This is another set of figures looking at a different set of parameters. So this is varying the viscosity of the magma. And I want to emphasize that all of this coding is being done by an undergrad. This is an undergrad who already knew how to do Python. He actually took this class from me last quarter and did incredibly well. And so I asked him if he wanted to work with me over the summer in order to put these notebooks into LibreText. And the things that he wanted me to share with you was that if you already know how to use the code, right, like either R or Octave or Python, whatever coding language you want to use in these notebooks, learning how to embed it is as simple as what Kamran showed you. You click on the binder button, you get this window, you enter your code. Really straightforward. So he was able to, after 1 week, he came back and he already had a working example. And then we started really thinking about like, well, how do we put this on the page and how do we make it accessible to the students? And so it's a really, they've made the barrier to adding this into LibreText really low. So I think that's an important thing to realize. So, this example, the code, this is, if you know Python, the code is interesting. Otherwise, it's not interesting. It's all just normal Python code. And we can have a whole series of examples here where we, run each one of these. This last one, we made a little bit more complicated. This actually shows the top layer and the bottom layer of the flow. This is the velocity profiles. And then we actually put these at the angle. So this is a plane that's dipping 10 degrees. The middle one is a plane dipping at 40 degrees. And the top one shows really, if you were at the very top of the volcano, how the magma would flow out of the vent right at the top, right? How these profiles change. And then at the bottom of this, we have these key questions, which we pose at the top of the notebook so that these are what we expect the students to be able to answer after they've gone through looking at working their way through this notebook. And my thought with these sorts of things is that like this would be the jumping off point for my own discussion in class, right? Everybody's worked through these. We would start out with a discussion of the answers to these key questions as the way that I would integrate this into my teaching. Maybe the only other point that I would make is that, so Nicholas, the student working with me, said, so this is a lot of code, right? It's a lot of code. And you don't want to debug this inside LibreTextbook. So the way that he's doing this is he's actually creating all of this code, running on his own installation of Python on his computer. And then once he has everything working, then he just copies and pastes into the LibreTextbook binder windows so that he knows everything is working before he puts it in here. It's just a bit faster in order to do your debugging and things like that, rather than try to do this inside LibreTexts. So I think I'll go ahead and stop there unless anybody has any questions.
We were asked a question in the chat, and it's actually a very good question that I hadn't thought about.
Okay.
If you have an interactive IDE, interactive development editor, you can stop a script that goes haywire.
Yeah.
What if a student changes your code? How do you stop a script if they go into an infinite loop or something?
Right. So, okay. So this is part of the reason, one, that we put in these statements so that they, hopefully the first time they would run something, they would just run it and they would see that there's this statement that comes out, or the, how long it takes for a figure to come out. So if they edit something and it doesn't work or it gets stuck, all they have to do is refresh the page. Nothing they're doing is being saved. So like when I edited this time sleep up here, like I could edit this and I run this, that's fine. But if I refresh this page, that's gone. So this allows the students they can break it, and they can't really break it. they can mess with it, they can experiment with it, but it's not actually saved. So if the students really want to be saving this and working with it, that's where the Jupyter Hub is really the resource that you want to be using. So in that case, the students can get all of my students for this class had an account on the Jupyter Hub. And they would upload the notebooks to their own account on that Jupyter Hub. And then we would actually, in our lab, we would edit and work on those notebooks together. And then they would save that and then re-download it to their own computer. And there is definitely a bit of overhead in teaching the students how to deal with a hub and understand what that is, that they're uploading their script to a different computer. They're running it on that computer because that computer is set up with all of the software and all of the packages that they need. But then if they want to save that output, right, they have to save it and put it on their own computer in order to like submit their script for their homework or something like that. But when you're interacting with this on the LibreTexts book, unless they have their own page and have editing rights, whatever changes they made will disappear. Oh, what does the restart button do? As far as I know, you should not press the restart button. You'll see at the top of my page, it says, don't click the restart cells in the cells. I cannot figure out what this does. When I click restart, nothing happens. And then I can't run after that. It just sort of gets stuck. So I would say, please only press the run buttons. Like I said, I just started using this literally in July, and it goes really quickly. But of course, there's a few things like this that I still don't know what the restart button does, and I haven't had a chance to ask.
So somebody that's a newbie to learning these languages, in particular, I'm interested in R, where do you go to teach yourself? Because obviously you need that to embed all this code, and I understand the code, and I have had programming. They're old programming languages, so at least I have some idea of what the concept is and everything.
A lot of students go to use YouTube. Are you familiar with DataCamp?
No, DataCam, you said?
So DataCamp is a site that has a lot of tutorials available, and a lot of the stuff is free. Some of it you have to pay for. You just gotta, Google, but there's DataCamp has a lot of material.
Okay.
Is there an R program in the LibreTexts? There very well could be.
I don't know.
So we're building stuff within the LibreTexts, and if we go to engineering, bookshelves, computer science, probably a search of R is not going to work very well, is it? No, it isn't. Okay, maybe I should have done.
I believe statistics, Bob. I think I came across one. So I put together a very, very short example that is one of the videos that's linked on the LibreFest page. And I ran across there's a book in the statistics library that uses R throughout and has lots of interactive examples.
Yeah, statistics would be a great place for R too. I know. Okay.
I also pasted into the chat the software carpentry website. They
Yeah.
have a lot of really introductory lessons, and quite a few of them related to R.
And Lori will be interested to know that there's several software carpentry examples that do microbiome analysis. So.
Okay.